Welcome everyone. So this video is going to be a bit intense because I'll be deriving the entire naive-Bayes algorithm here. Uh, so please focus. So here X is the uh, feature set, right? So basically the features, the columns x1, x2, so the dimension is basically d the number of columns are present in my data set. So assuming that, what I am doing is I need to find out probability of ck, where k is the number of classes in my class variable, given this x. This is what we need to find out in the prediction phase, right? So this is equal to what? This is equal to probability of c given x given ck into probability of ck by probability of x. This is from the Bayes theorem. We know that, right? Now, what we can do here is we can write it like this: probability of ck intersection x by probability of x. We can write it, right? Because this is conditional probability, right? From the same definition we can write it like this, and intersection can be written like this: ck comma x. It is same, intersection means comma. We can write it like this, no issue. Okay, now in the next step what we'll do is we'll simply write probability of ck given x is proportional to probability of ck comma x. How did I write this? This left hand side is this one, and here the numerator is this. I am actually deleting the denominator because for all the classes k, or for all the k classes, the denominator is similar, right? The denominator is p of x, probability of x, so it is common. So what change will it bring? It will have no effect at all, because the denominator for all the classes will be same. Then for example, probability of x is 0.5. So for c1 given x, the denominator will be 0.5. For c2 given x, the denominator will be 0.5. So for all the classes, all the probabilities of class given x, the denominator will be same, so we can simply discard it. That's what I am writing here, proportional. Okay, we do not need to have this because we simply need the which value is greater, right? And since the denominator is same, it will have no effect at all. Hope you understood it, right? So I'll just again explain something like this. Say the denominator is 5. 4 by 5 is say greater than 2 by 5. If I say like this, if I say it like this, what do we mean? Is this 5 important? What do you say? What is 4 by 5? It is 0.8. What is 2 by 5? It is 0.4, right? So obviously we simply can take the numerator because the denominator is same, right? It doesn't make any sense, so we are just discarding it. So after we have discarded it, what we have this. So let's say this is equation 1. Okay, now let's say probability of ck comma x equals to, we can simply expand it, ck comma x1 comma x2 likewise up to xd. We can write it, right? We are simply expanding the x, which is equal to, I'll just interchange the value. I'll write x1 x2 likewise up to xd comma ck. Okay, now let's assume this is a and this entire thing is b. Let's say, now what we can write for this, if this is a, this is b, then what we can write? We can use this. See, probability of a given b is equal to probability of a comma b by probability of b. We know this, a intersection b, this is basically. So if I find out, if I take this, find out a comma b, then it will be like this, just by interchanging. Hope you understood this. Now what is probability of a comma b? Let's say this is a, this is b, a comma b. what will be the result? It will be probability of A given B. Okay, I'll just write in a new page. So probability of ck comma x, so probability of ck comma x equals to, what is it? Probability of, I'll again write it. Okay, probability of x1 comma x2 up to xd comma ck. Now I am just assuming these as the A and this entire thing as the B. So what can I write here? I can write it like this: probability of x1 given x2 x3 likewise up to xd comma ck, right, into probability of x2 comma x3 comma up to xd comma ck. This is what I can write. How did I write this? Just using this. I'll write it again here. Probability of A given B equal to, we know it as probability of A comma B by probability of B. So now if I find out probability of A comma B, what I will get? I will get probability of A given B into probability of B. Here I have simply found out this. If this is A, this is B, so probability of A comma B is basically A given B multiplied by probability of B. This is basically B. Okay, hope you got it. Now next we can expand it again. We'll just keep it same, the first part up to xd ck. Let's keep it same and we'll break this. So what will happen? Let's say now this is A and this entire thing is B. What will happen? So probability of x2 given x3 up to xd ck, this is one part, multiplied by probability of B. What is B? Probability of x3 x4 likewise up to xd comma ck. Okay, we can keep on expanding it, and finally what we'll get? We'll get something like this: probability of, okay, let's not write it here. So here itself, if I keep on expanding it, so it will be a multiplication of, I'll just put a dot dot dot, keep on multiplying. It will be probability of x d minus 1. Let's not write it here. So it is continuing. Okay, so I'm continuously expanding it. Then I'll multiply probability of x d minus 1 given x d comma ck multiplied by probability of x d given ck multiplied by probability of ck. Let's say this is equation number 2. Okay, this is simply I'm just expanding it continuously. Okay, after continuously expanding it, this is what I will get finally. Okay, this is what I will get. Now once I have got this, what I need to do? This is very complicated. Okay, this is what I need to find out in order to get this. Okay, so this is very complicated. This is basically what is p of ck given comma x. This is nothing but ck given x. This is ck given x. This is nothing but probability of ck given x, right? So I can write this is basically probability of ck given x. This is what we need to find out ultimately. So ultimately what we need to find out boils down to this big result, this huge complicated equation, and this is very tough to find out. So here we'll actually assume a naive assumption. We'll take a naive assumption. What is a naive assumption? that all the features x1, x2, x3, x4, all these features are conditionally independent of each other. That is why you will use the conditional probability concept. So we are assuming that all the features x1, x2, x3 up to xd are independent of each other, conditionally independent of each other. Then what will happen? What was the definition of conditional probability? Probability of A given B is equal to probability of A, right? You already know this. So we can rewrite this equation as probability of x1 given ck. We can remove this part because this has no importance, right? Because they are independent of each other, so they will play no role. In the same way, I can write probability of cx2 given ck, so on, right? So on. At the end, I will have probability of xd minus 1 given ck multiplied by probability of xd given ck multiplied by probability of ck. Okay, this is what we get finally, right? So what we can write? So probability of ck given x is equal to, what is it? It is nothing but 1 by p of x multiplied by probability of ck, and then we have a product where it is going from I equals to 1 to d, probability of xi given ck. How did I write this? This is what we got now, probability of xi given ck. You can see this, probability of xi given ck for x1, x2, x3 up to xd, right? And this p of ck, probability of ck, this is this probability of ck. This is common, right? That's why outside the product. This is basically product of xi given ck. This is probability of xi given ck. See, x1, x2, x3, x4 up to xd, right? So we got this. And what is 1 by p of x? Remember, we discarded something at the beginning. This probability of x, this was in the denominator, 1 by p of x. So we took it as proportional. So let's, that's I have just used it here, 1 by probability of x. That's it. This is the final equation. Okay, but obviously this p of x is will remain same for all the classes. That's why we can discard it. No need to write this. Okay, you can discard it. This is your final naive Bayes formulation. Okay, probability of ck into this. In the next video, you will see the example where I'll be finding like this, probability of ck here, say yes given x. Okay, x is basically x1, x2, x3 up to xd, or for the given example I'll be having 4 features, so x1, x2, x3, x4. Okay, will be equal to basically probability of yes multiplied by probability of, this is x1, okay, given ck multiplied by probability of x2 given ck, sorry, this is basically probability of x1 given yes. This ck is basically yes for this, right? So I'm using yes, probability of x2 given yes into probability of x3 given yes into probability of x4 given yes. Okay, this is the final formulation. This is what this formula is saying, this equation is saying. Same way we'll find out the probability for no given yes, which will be probability of no multiplied by probability of x1 given no multiplied by probability of x2 given no, probability of x3 given no, and probability of x4 given no. So we'll find this. This is the final formulation of naive Bayes given binary class. So yes and no. If this was 10 class, then we'll have to find for all the classes. Okay. So whichever value is greater, I will say the prediction as that value. Okay. So this is the formulation. This is the entire derivation of naive Bayes. So I hope you understood. The main goal was not to do it on my own, everything on my own. Okay, because this is a bit complicated derivation. My goal was only to make it clear to you. Okay, so that you can understand how the derivation is done. I hope you understood, and in the next video you will see the example, and from that you will be understanding the entire naive Bayes, how it works behind the scenes. Because you see in sklearn or any package in Python, you will see that naive Bayes on all these algorithms are implemented directly, right? You just need to write 3 lines of code to implement it. But why to use it, naive Bayes? Where to use naive Bayes? In what conditions naive Bayes will fail? You will understand that only when you understand this entire algorithm. So that's why I have explained it. Hope you liked it. Thank you. And if you have any suggestion, you can leave it in the comment section. Okay, thank you. See you in the next series.